Okay, today is Tuesday, October 30th. Okay, Tuesday, October 30th. So today you do not really need a calculator. This is all about expanding. So we're going to use product property of logarithms. We're going to use quotient property of logarithms, power property of logarithms, and properties of logarithms together. Like we're going to put all three of these together. These are to help when you're solving equations with logs to make it a little bit easier. So we break it down into three of them. There's three properties today. So number one has to do with multiplication. So it's called the product property of logarithms. And it has something to do with multiplication and addition together. So we're going to go back to our rules of exponents, back from Algebra 1. What is the rule when you multiply two exponents with the same base? So same base, you have a 2 and a 3. What you're supposed to do is you're supposed to add these. So your answer would be x to the fifth. So you add the exponents. When you're multiplying, you're really adding the exponents. So this has something to do with logarithms. So what it says is multiplication inside the logarithm. So right now, see, this is inside the logarithm. See how you're multiplying these two? This can be turned into addition outside the logarithm. So this is an example. So you have log base b of x times y. So this is called a condensed form. And then what they want us to do is expand it. So you count how many factors you have, which are 2 of them. And you write log base b twice. 1 for each factor that you have. So log base b of x plus log base b of y. So you were multiplying here, but you will add in between them. So it's just like this. When you multiply with exponents, you add them. And the reason it's the same as this is because a logarithm just represents an exponent. So you're really just adding the exponents. So here's 2 examples that we can do. So this is a log base 6 of x times x plus 2. Factors are separated by time signs. So this is one of your factors, and x plus 2 is the second factor. So since there's 2 of them, what we're going to do is we're going to write log base 6 twice. The x goes with the first one. The x plus 2 goes with the second one. That kind of looks weird, so you need to put like parentheses around that because it's more than one number. And then, since you're multiplying here, when you expand it, you add there. And that's all you have to do. No calculator or anything. So in this one, this is already expanded. So this is expanded form. So this time we're going to condense. So what does that mean? It means right now there's 2 logs with base 3. What you were going to do is write 1 log with base 3. And we're going to take the 1/2. Instead of plus 12, it's going to be 1/2 times 12. So when you condense, the addition goes back to times. And now if you can simplify this, you should. 1/2 times 12 is 6. And that's your answer. That's condensed. So it went from here to here. So when we're solving an equation, it's sometimes easier to condense to make the problem easier. So now let's go from quotient property of logarithms. The quotient property of logarithms has to do with subtraction. Let's write subtraction in here. So division inside turns into subtraction on the outside. That has to do with this. Back our rules of exponents. Division. When you're dividing x cubed by x squared, you write the base once and you subtract the exponents. And you just get x. So you subtract the exponents. So when you see division, you are really going to write it on one single line here. You're not going to write it as division. You're going to write subtraction instead of division. So if you see a problem like this, I see division, but I want to take care of the division. I want to expand it. So I'm going to write log base 2 twice because there are 2 factors. The 5 goes with the first one. The 7 goes with the second one. And you put a subtraction there. That's called the quotient property of logarithms. Now usually you don't want to do this. It's better usually to condense. So to condense, you're going to write log base 4 once. When you see a subtraction, I want you to think division. So this is what you're going to have. Now, if that can be simplified, you should simplify the fraction. And that fraction can be simplified to 3/4. So that might be a little bit better. Power property of logarithms. So an exponent to everything inside. So say this R exponent. I really can't do anything to this. So what we're going to do is, what you do is you bring it out front and make it a factor, R times this. So this R is interchangeable. It can be as an exponent or it can be out front. It's whatever's best for you in the problem. The reason we can do that is because in our exponent laws, when you have x squared cubed, you're not really cubing the 2. You're actually multiplying these two numbers. So it's x to the 6. You're actually multiplying them. So we want you, when you see an exponent, we want you to think multiply. So we're going to multiply. So the first property has to do with addition, subtraction, and multiplication. So here's an expansion one. Now this one, maybe you don't know this, but the square root of x can be rewritten as x to the 1/2 power. For example, if I said, what's 9 to the 1/2? That's the same thing as the square root of 9. So that answer would be 3. So what's 16 to the 1/2? A square root of 16, which is 4. And if you had like 8 to the 1/3, that's the cube root of 8, which is 2. You did all that stuff last year. So when you see a square root of x, you can go backwards and make it a fractional exponent. So you can write radical x or 1/2, but we don't like, logarithms don't like radicals. So if you see a radical, make it a 1/2 exponent. Then this can release, now it can only release out front if there's a log in there. This doesn't work unless there's a log. So it releases out front, and this is your answer. So what would happen if you want to condense? Now you're not allowed to condense if there's a number out front. So what you need to do is put it back as an exponent. So we're going to write log base 3 of x to the 4th. And that's condensed. I mean, they're kind of both condensed, but there's two ways of writing this. 4 outside or 4 as an exponent. So an exponent to everything inside can be turned into multiplication in front of the logarithm. So on the back, you're going to mix these up. So it says right here to condense. That means single logarithm. But there's 2 of them. I am not allowed to condense if there's a number out front. That's showing, it's like 2 times. So what we're going to do is we're going to use the property that we just did, the power property, which says that it can be out front like this, or it can be as an exponent. So we're going to write it as an exponent. We're going to write the 2 as an exponent for 3. And we're going to do the same thing to the 3. We're going to make the 3 back an exponent. We're putting it as an exponent. Once you have a single log, like there's nothing out front of the log, then you can write it once, like that. So we're going to write it once, because that's what condense means, write it once, and then we're going to take this 3 squared, and we're going to multiply it to this 4 cubed. So log base x, this is kind of big, log base x, this is 9 times 64, which is, I don't know, on your calculator, what is 9 times 64? 9 times 64 is 576. That's the best way of writing that problem. It went from here to here. So in this problem, what are we going to do with the 3? I want you to move the 3 here. That's called the power property. That's when an exponent can be as an exponent or it can go out front. But right now it's out front, but we want to make it an exponent. Then, let's just rewrite this. Okay, so now we have this. I didn't do anything to the second one. Do you see how there's nothing out front of either log? If there's nothing out front, that's when you can go ahead and condense. Now, what happens when you see a subtraction? So when you see a subtraction, like in this one right here, what we're really going to do is divide. So this is called the quotient property. We are going to take x cubed, that's in the top. Anything that's, if it's got a positive sign out front, it goes in the top. If it has a subtraction sign out front, that goes in the bottom. Now notice I'm only writing log base 7 once. You're only allowed to write it once. That's what condense means. So don't write it twice. You write the log base 7 once, but then you take this and you divide this. And that's your answer. So in this one, nothing's out front of the log. That's good. Nothing's out front of log. That's good. And you do have something out front of this one. So this one needs to move before we can do anything. So I'm going to rewrite everything else. And I'm going to write this one as log base 5, 2 to the 5th. That's what the first thing you should do. And what is 2 to the 5th? So I'm going to rewrite all these again. So this is really log base 5 of 32. If you look at your sheet, 2 to the 5th is 32. So this is what I have. Single log, single log, single log. We're going to take all these single logs and make it one single log of base 5. So anything that has a positive in front of it goes in the top. See how this is a positive, positive? That means 64 and 4 go in the top. But the one that has a minus in front of it, that 32 goes in the bottom. So on your calculator, take 64 times 4, press equals, divided by 32, and that's an 8. So your answer is log base 5 of 8. That's your answer. So this time we're going to expand. Okay, so when you expand, you need to write log base 11 more than once. So how many times do we write it? Well, it depends. How many factors do we have? We have 3 factors. 13 is a factor, x is a factor, and 10 is a factor. So I'm going to write log base 11 3 times. Start like that. 13 goes with the first one, x goes with the second one, and 10 goes with the last one. If they're in the top, there should be a positive sign up front. So I don't need to write a positive because I already know it's positive, but this one needs a positive sign. But if it's in the bottom, there needs to be a subtraction before the log. And that's it. That's expanded. How many factors do you see this time? Did you say 2? You are right. So we're going to go log base 9, log base 9, and then r to the 6th and t to the 2nd, like that. Now, notice these are divided. See the t squares in the bottom? That means there should be a subtraction here. Now, you would be done if you didn't have any exponents in this problem, but because you have exponents, we're doing this property. So if you have an exponent, it's going to come out front like this. So we're going to bring the 6 out front, make it 6 times log base 9 of r minus, bring the 2 out front, 2 times log base 9 of t. And that's your answer. So I've been saying this whole long. The whole purpose of doing these is to solve an equation. So do you see the equation now? We are solving for x using properties. So what I would like to do is get this down to a single log so that we can swoop. I can't swoop if there's 2 of them. But I can't write these as 1 until I get rid of the 3, until I get rid of the 2. So what are the 3 and the 2? They are exponents. So write the first one like that. Minus 2, oh, not 2, whoops. Log base 4 x squared. Are you guys okay with that? I made the 3 an exponent, and I made the 2 an exponent. All this equals 2. Now I can write this as a single log. Log base 4 of x cubed divided by x squared. Why am I dividing? Because there's a minus. All this equals 2. Now, simplify this if you can. X cubed divided by x squared. I think I just did that over here. Look, x cubed divided by x squared. You subtract your exponents and you get x. So this whole thing is x equals 2. At this time is when we go ahead and swoop. Because once you get down to a single logarithm, you can swoop. So 4 squared equals x. So 16 equals x, or x equals 16 is your answer. And we solved it. So over here, now we have 3 of them. 3 of them. So we got to get these down to 1. But what's the only one that's not ready to go? This one's good. This one's good. But see that 3? This 3 should become an exponent. So I'm going to have log base 2 of 4 plus log base 2 of 32 minus log base 2 of 2 cubed all equals x. You see that? I made that a cube right there. Now I can go ahead and use my properties. So 4 goes in the top, 32 goes in the top because it's a positive out front, but because that's a minus, the 2 cubed goes in the bottom. And what is 2 cubed? 2 cubed is 8. 2 cubed is really 8. So I'm going to replace 2 cubed with 8 in the bottom there. All this equals x. So 4 times 32, I'm going to simplify the fraction now. 4 times 32 equals, divided by 8, is 16. So this whole thing here is 16. Now we're going to swoop. And 2 to the x equals 16. Okay, get your paper out. Look in the 2 family. What's another way of writing 16? 2 to the 4th. So 2's cancel and x is 4.